Hello. Today we're talking about monomials and all their properties. Now there's quite a few in here, so you may have to rewind and go back because there's a lot here. So first of all, a monomial is an expression that's a number, a variable, or the product of a number and one or more variables. Monomials cannot contain variables in denominators, variables with exponents that are negative, or variables under radicals. So as you take a look at this, the monomials are examples like 5b, negative w. 23 is just a plain old number is a monomial. X squared is a monomial. 1/3 x cubed y to the 4th is a monomial. You can have fractions as numbers in it, but you can't have the variables on the bottom. Take a look at the not monomials. 1/4 to the n to the 4. Because of variables in the bottom, that is not a monomial. A cube root, not a monomial. Square roots, that's out. Anything that has a plus in it, that is not a monomial. And if it has a variable of a -1, it's not a monomial. Okay, so let me show you a pattern. I'm going to kind of go backwards a little bit, but if I had, say, 2 to the 3rd, you would call that 8. If I had 2 to the 2, you'd call that 4. If I had 2 to the 1, you'd call that 2. And if I had 2 to the 0, well, look at the pattern. One way I can go from 8 to 4 is to divide by 2. If I divide by 2 again, I'll get down to 2. So as I drop in exponents, I'm taking away each of those 2's. So 2 to the 0, to follow the pattern, what do I get if I go 2 divided by 2? 1. In fact, anything with an exponent of 0 is a 1. 3 raised to the 0 power is 1. 4 raised to the 0 power is 1. 5 raised to the 0 power is 1. X raised to the 0 power is 1. Well, we can keep on going with this pattern. What would 2 to the -1 be as I keep going down? Well, take the same one and let's divide it by 2. What do you get if you take a whole and divide it by 2? You get 1/2. Let's divide it by 2 again. So 2 to the -2 would be 1/4. Cut it in half. What's 2 to the -3? Again, follow your same pattern. Divide by 2. You get 1/8. So we can draw a lot of conclusions from this pattern. And the idea is that notice how 2 to the 3rd was 8. 2 to the -3rd also had an 8 in it. So what does this negative sign do? This negative sign flips and puts 8 over. It turns into the reciprocal of that. What's the reciprocal of 8? 1/8. What's the reciprocal of 2 squared, which is 4? 1/4. What's the reciprocal of 2? 1/2. And so you can look at these negative signs in exponents and think of them as reciprocals. They flip it. They make it 1/. So you can actually do these separate. You can say, okay, a 2 to the 3rd is an 8. With that the negative in the exponent, it's going to be 1/8. So here's the key concept. For any real number, when a is not 0, in any integer, any variable a to the -n is the same thing as saying 1/a to that n. Likewise, what if it starts out on the bottom? 1/a to the -n, then that negative is going to reciprocal it, which is going to bring it back up to the top. And it's like having it over 1. So it brings it back up to the top as you get. So that's what this negative sign does. Now, to simplify, and this is pretty important for you to know, to have an expression simplified, you cannot have a negative in the exponent. So if you're simplifying this 2 to the -3rd, and you know it's the same thing as saying 2 to, or it's say 2 to the third is an 8. 8 to the negative 1 is still, you have to write that as a 1 over 8. So you can't have that negative in there. It's not simplified until the negative and the exponent gone. By the way, that negative does not make your answer negative. So the negative in an exponent does a different job. It doesn't quite treat it as normal. So it's not changing this 8 to a negative. It's still a positive number. Okay, so what else can we do with powers? Powers, we can add them. If I had, and I'm going to start here with this b to the third here. We know that's b times b times b. B to the 5 is b times b times b times b times b. So if I count them all, notice they're all just multiplied together. This multiply in the middle really doesn't change anything. It's all multiplying. So I have 8 of them. So I can just write this as b to the 8. And so the shortcut is hey, if I realize that when I'm multiplying the bases, the shortcut is I can add those two together. So if I have a to the 3 and an a to the 5, I can just simply go a to the 3 plus 5 equals a to the 8. Likewise with dividing. If I'm dividing, I can do the exact same thing. So if I have x to the 7, that's x times x times x times x times x times x times x. 7 of them on top. Divided by x to the third, that's 3 of them on the bottom. Remember, I can divide 1 on top with 1 on bottom if it's the exact same thing. This x cancels with that x, this x cancels with that x, and I'm out of x's on the bottom. What's left? Well, that is just x to the 4. Faster way to do it may be to subtract them. X to the 7 minus 3 is x to the 4. You get the same answer either way. So properties. What else happens? Okay, what if we have a power to a power? If I have a to the 2 to the 3, this is like saying I've got a to the 2 times a to the 2 times a to the 2. That's a times a times a times a times a times a. So each of them have 2 pair. That's a to the 6 altogether. Faster way to do it is when you only have one base, you can multiply those 2 together. A to the 2 times 3 is a to the 6, and you can get there faster. If you have 2 variables inside parentheses and an exponent outside the parentheses, this acts like it distributes to both of those. So you get a to the m times b to the m. The power of a quotient, same thing. Whether to multiply or divide, the property is the same. This n is going to distribute to the a and the b. If it's a negative sign, remember, it takes the reciprocal of it. So if there's a negative outside here, we're going to take this and flip it. The reciprocal means kind of flip-flop. And you'll have b over a over n. And then you can distribute it. So they're going to give you problems like these. You got 2 options. One, you can distribute the 4 to everything in here. But what I personally like to do is to simplify it. So notice, I'm going to take and start with the 8 and the 16. Work with your like terms a lot, okay? 8 divided by 16. I can divide both top and bottom by 8. That's going to leave a 1 over 2. Divide them both by 8. Next, look at the a's. I got 3 a's on top, 2 a's on the bottom. 2 of them are going to cancel with a 3 on top. That's going to leave just 1 a left on top. Now be careful. Watch what's up on top and on bottom. And the b's. I got 2 b's on top, 1 on the bottom. I'm going to take the 2 on top and cancel them with at least 2 of them on the bottom. That leaves 1 b left on the bottom. I'm going to write that down on the bottom. The trick with this thing is that watch out for where you're putting these things. Where's the top? Where's the bottom? Now, I still haven't done anything with the 4. And I like simplifying the insides because now I have less to distribute to all 4 of those. So when I do that, that's going to equal a 1 to the 4, an a to the 4, over a 2 to the 4, and a b to the 4. Now I can simplify it. 1 to the 4 is still just a 1, so that equals a 1. 2 to the 4 is a 2 times 2 is 4, times 2 is 8, times 2 is 16. A to the 4 is just stays an a to the 4 on top, and b to the 4 is just a b to the 4 on bottom. There's no negative signs, so it's simplified. Scientific notation. Remember, the rules are you get one non-digit number in front of your decimal. And then you have to have a times 10 to the some exponent. So if I had 4.1 times 10 to the third, remember that just says moves the decimal 1, 2, 3 spots. So that's 4 to the, let's see, 1, and fill the rest in with 0. So 1, 2, 3 spots. There's my new decimal point. 4,100. Okay, so what if I'm multiplying these two guys? My idea is to write 4.1, but these are all multiplies in here. So you have the commutative property. So let's commute these two around. So you have times 3.0 times 10 to the third times 10 to the squared. Well, I can multiply these two together and get 12.3 times, and I can multiply these two together, and remember, same base, add the exponents. So 10 to the 3 plus 2 is 5. So 12.3 times 10 to the 5. Now remember, it's not quite in scientific notation, so I'm going to have to take this decimal and move it over one spot, so that'll be a 1.23. But as I do this, times 10 will go from 5. I've moved it 5. Now it's going to turn to a 10 to the 6. Dividing works the same way. Divide these two numbers together. 6.3 divided by 2.1 is going to be just a simple 3 times 10 to the 7, and over 10 to the 5. I got 7 tens on the top. I got 5 tens on the bottom. Divide all 3 5s out of the bottom with 1, 2, 3, 4, 5, and you're left with 10 to the 2. Hope this helps.